So like I explained, the sessions are recorded. So every week I'm not going to be able to always tell you that the sessions are recorded. So now you know that the sessions are recorded. And every week when you come in, please make sure that you switch off your video and you unmute yourself. The code is not on the drop-down list. Okay, we will deal with that. I will ask them to send me the new form or include it in the link. For now, let's not worry too much about it. If it's not there, or if there is an other, you can use the other. But I will prefer the module to be part of the drop-down. Otherwise, you can use the WhatsApp link later on to register yourself. Okay, so let's do stats. My name is Elizabeth. You can also call me Lizzie. My surname is Boy. And I will be your facilitator for the rest of the semester until you go write the exam. So I am here to help you unpack your STA1502 in the skills facilitated manner. So I might not do the whole content as you would like digging deep into theories and I'm just going to give you the skills on how to unpack some of the questions and answer some of the questions that you might have, but giving you the skills also to understand what is needed to answer those questions as well. Because this is not tutorials, we do skills literacies. Okay, so today, since we started 10 minutes later than the time actually, so in the next 20 minutes or so, or 30 minutes or so, we're going to look at the inferences about the difference between two population means by looking at when the variances of those populations are unknown. So if the population variances are unknown, we're going to first look at the hypothesis testing. How do we apply the hypothesis techniques to answer some of the questions? And then later on, we're going to look at how do we calculate the confidence intervals. And then later on, we do lots of other exercises. If we have enough time, we will do more exercise. But in between, I would like to take at least a 5-minute break, breather, so that everybody can stand up from where they are, because we would have been sitting for almost an hour. So you can distract yourself with something else and then come back and concentrate on the exercises as well. So we will see how this goes, but the session will end at 7 o'clock. So, like I said, before I even start going further, do you have any question? Because I haven't even heard that you are able to answer questions there, or your mics are working or anything. That's bad of me. Do you have any question or any comment? Any question or any comment before I start? All good, Tiffany. Thank you very much. Okay, so we can start looking at the inferences about difference between two populations where the population variances are unknown. And we're only going to concentrate on the hypothesis testing. So when comparing two independent samples, which means two samples that you would have drawn from the population, from two independent populations as well, we're going to be using what we call a pooled variance t-test to calculate the difference between the two, or to test the hypothesis between those two differences in the means. So what do I mean? So because the variances are unknown, there are some assumptions that needs to be made. And those are the things that you need to know whether, or pick up to see whether the population variants are not are unknown, and does all these other assumptions are they met based on the question that they have given you. So one of the question is that the population, or one of the assumptions will be that the population should be normally distributed. And in the question, they will state that the two populations are normally distributed with the mean of this and the standard deviation of that. So they should mention that they are normally distributed. Then they also, the sample also should be from a randomly and independent sample. So they should be drawn from the population in a random manner. So they will say a sample size which collected from a randomly selected sample collected from the population. One is this, and it is independent. So they should mention all those type of statements in your question. And another assumption is that the population variance, which is the sigma for population 1 and population 2, both of them should be unknown and they should be equal. So it means the population variance for one should be 8 and the other one as well should be 8, because if they are unknown, so we're going to be using the sample variances. So if we use the sample variance, then it means the sample variance, if we get it's 8, and on the other side, the sample variance we get should also be equals to 8. Therefore, they are equal, even though the population variance will be unknown. And if both populations are not normal in this instance, then the sample size needs to be large. And by large, we mean at least the n should be greater than 30 for you to be able to use the pooled variance t-test. Okay, so when we talk about hypothesis testing, actually, there are 6 steps that you need to know before you even start calculating anything. So if you can master these 6 steps, then you can answer any question in the exam or on your assignment when it comes to the hypothesis testing. So the first step is always to state your null hypothesis and your alternative. This is the same as two sides to the coin. One side is a head, one side is a tail. So this is what we're going to prove. We're going to prove that a coin has a tail, but you also know that it has a head. So you're going to prove that statement. So if the researcher says, oh, but this coin that I have lands on a head, you must say also it can also land on a tail. So you need to prove that one statement is correct. And that's what the null hypothesis is for. It's like proven innocent until, or proven guilt until something like that. You are proven innocent until you are proven guilty, something like that. Oh my goodness me. It goes with that notion that you are innocent until you are proven guilty. So that's the null hypothesis statement. Then we also need to know what the level of significance is. And the level of significance is very important, which is what we call the alpha value. Sometimes they will give it to you as a confidence level and say at 95% confidence level, this, test the hypothesis. But you need to know what the alpha is, because your alpha will be 1 minus the level of significance, or 1 minus the confidence level. You also need to know what your sample sizes are, because then you will be given 2 sample sizes. So a sample size 1 and sample size 2. You will need to know those ones. Then you need to determine what will be the appropriate test. But in this instance, we know that we're doing the t-test. And since we're doing the t-test and we know those assumptions, if the population standard deviation is unknown, then we know that the test statistics that we're going to be doing is t-test. And that is what you need to know. And that will also help you when you go find the next step, which is your critical value. So if you know that you're doing what kind of a test, which is a t-test statistic, then it means you know how to find the critical value. And finding the critical value, it means you will need to go to the t-table. On your t-table, you will find those critical values. Now, where do I find those t-tables? You will find your t-tables at the back of the past exam paper. They always have the tables. I will show you later on. when we are busy with the exercises, how to find those critical values. And also, if you have a prescribed book, sometimes at the back of the prescribed book, they do have those tables. If not, I will say stay away from using the internet tables because sometimes they are very confusing. They don't look exactly the same as the ones that your lecture is using. You will need to understand each table on the internet is created differently to answer certain type of a question. So you might be using a cumulative table, whereas you should be using a standardized table. So use the one at the back of your past exam paper or the one from your prescribed book. So that is step number 4. Step number 5, for doing all this, you will need to know how to compute your test statistics. Knowing that you're doing a t-test, you will need to know how to solve that test statistic. There is a formula in the exam. You also need to be able to know which formula it is. How does it look and how do you calculate it? You will have to do that. Then step number 6, after you have calculated your test statistics and you have found your critical values from your table, then you can make your conclusion. And you make your conclusion by referring back to your null hypothesis. So you make your decision and then you conclude by referring back to your null hypothesis. Whatever you have stated in the null hypothesis or alternate, you go back and refer back to that. Then let's look at how we do that. So how do we even start setting up a hypothesis for t-test? So there are different types of hypotheses that you can state. For example, the first one that you can do is a two-tailed test, which states that the null hypothesis for the mean population 1 is the same as the mean population of 2, where the alternative will say they are not the same. And this is a two-tailed test. The other type, you can do a one-tailed test. You can also rewrite it in another manner. So you can say mu1, which is the mean population 1, is equal to the mean population 2. Or you can say mean 1 minus mean 2 will be equals to 0. They mean 1 and the same thing. And this is your two-tailed test. Then we also have a one-tailed test. And you will notice when we find the critical value, it also is dependent because once you state your null hypothesis and your alternative, you will know which your critical values that you're going to find, where to place them in order for you to make the decision, and we base that on the null hypothesis theories. So for a two-tailed test, then it means you will have 2 regions of rejection. And for a one-tailed test, if I look at this, you will only have 1 region of rejection. And this one says your mean 1 is less than your mean 2, and your alternative will say the opposite of that. And we can also write it as that, and this will be for the right-tailed test. So it means the rejection area is only on the right side of the table or of the graph. And I will show you just now. Then the other part is a one-tailed test also, where it says it's greater than, where the opposite will say it's less than. We can also write it as such, and the rejection area will only be on the left side of the graph. And how do we even start calculating all this t-test? To calculate the t-test as well, you first need to calculate the pooled sample variance. So the formula, you will need to remember that for pooled variance, the formula is SP squared is equals to your sample size 1 minus 1 times your sample variance for 1 squared. That is your sample variance. You don't have to square the answer unless they gave you the standard deviation. Then if they gave you the standard deviation, you will have to square the standard deviation. Minus N2 minus 1 times the variance of the sample size 2 divided by your sample size 1 minus 1 plus your sample size 2 minus 1. And that is the formula to calculate this pooled variance. To calculate the test statistic, remember we're doing a t-test statistic. To calculate the test statistic, the formula is T representing the t-test, which will take the mean of a sample size 1 minus the mean of a sample size 2 minus your population mean 1 minus the population mean 2. And where do you get this? Remember, in your hypothesis testing, we said it is equals to 0. So always the mean minus mean 2 for the populations will always be equals to 0. So that will be the mean 1 minus the mean 2, and this will always be equals to 0. Divide by the standard error, which is given by the pooled sample variance. Remember that variance, the long formula that we calculated, it's always good to calculate the pooled variance outside so that you just use that one value and substitute into the formula. So into the variance, the standard error, which is the square root of the pooled variance times 1 over the sample size 1 plus 1 over the sample size 2. And when we go find the critical value, we're always going to look for the degrees of freedom. We're going to use alpha and the degrees of freedom for finding the critical value. So you must always remember your degrees of freedom for the pooled variance, where we calculate the t-test. The degrees of freedom is n1 plus n2 minus 2. And this we're going to use when we find the critical value. So let's look at an example. If this is your if you are a financial assistant for Charles Schwab and there is a difference in average dividends yield between the stock listed on the New York stock market and the Nasdaq, you collect the following data. So you take the sample of the information you collected from the New York Stock Exchange and the Nasdaq, and you said from the New York Stock Exchange there were 21 sample sizes, and from Nasdaq there were 25, and you calculate the average, which is your sample average for both of them. For the New York one is 3.27, and for the Nasdaq is 2.53, and you also calculate the standard deviation. If you notice here, we are given the standard deviation, not the variance. So when we calculate the pooled variance, so we will have to square the standard deviation. And we are given the standard deviation for both of the sample sizes. Then the question will be, assuming the variance, is there a difference in average yield at alpha 0,05, which means they give us the level of significance of 0,05. So how do we then start? So we can start by calculating the pooled variance. So the beginning, actually, I am skipping all the steps. So in the beginning, you will have to go and state the null hypothesis, because they said, is there a difference? So you know your hypothesis will state that the mean 1 minus mean 2 for the population is equals to 0. Because if I look at the question as well, it doesn't give me the idea that one is bigger than the other one. So it doesn't say, is there the mean for population 1 is different to the mean for population 2. It says the average is different. So it doesn't give me the idea that one is bigger than the other one. So therefore, it means we're doing a two-tailed test. So the first step, we calculate the pooled variance. We use that formula. We substitute. We know that our sample size n was 21, and for the n2 was 25. So you can see that your n minus 1, which is 21 minus 1, and remember we were given the standard deviation of 1,30 for the New York exchange. So we square the standard deviation plus the sample size of the Nasdaq, which was 25 minus 1, and also the sample standard deviation was 1,16. So we square that. Divide by your sample size 1 minus minus 1 plus sample size 2 minus 1. So it's 21 minus 1 plus 25 minus 1. And if you calculate the whole equation, you get that the answer will be 1.502. Then to calculate the test statistic, remember the mean we were given, it was 3.274 New York Exchange, and the mean for Nasdaq was 2.53. So we substitute that, and the hypothesis stated that mean 1 minus mean 2 is equals to 0. So therefore, it's always going to be equals to 0. Our pooled variance, we calculated that, and we can just substitute it into the formula. And also your N1 was 21 and your N2 was 25, and you calculate your test statistic. Once you have calculated your test statistics, now you are ready to make a decision. So if we go back to the beginning, remember the 6 steps of hypothesis. So we test the hypothesis. Null hypothesis, we state the null hypothesis and the alternative hypothesis. The mean minus the mean is equals to 0, or we can say the mean is equals to each other. Step number 2, state what you are given. Our N or our alpha was 0.05, which is the level of significance. And we know we can calculate our degrees of freedom. Remember, the degrees of freedom was N1 plus N2 minus 2. So N1 was 21, N2 was 25. We subtract 2, and the answer we get is 44. We're going to use the degrees of freedom when we do the next step, which is the critical value. So now we're going to find the critical value. Finding the critical value, it means finding the region of rejection. So since we are doing a two-tailed test, we always going to look at the alternative side. Usually the null hypothesis, it doesn't matter whether there is equal sign or not, it's always going to be equal. There is always going to be an equal sign on there. But under the alternative hypothesis, the sign here should not contain an equal sign. Therefore, if it's not equal, therefore it's a two-tail. If it's less than, then it's a left tail. If it's greater than, then it is and then it is a right tail test. Okay, so now, before I even continue with this, let me show you how you find on your T-tail test your degrees of freedom. So we're going to use our T-table. So I'm going to go out of this one and go into the table. I should have shared my screen. So now I will need to share the PowerPoint, not the PowerPoint, but the, okay. So if you go to the back of your past exam paper, you will notice that there are a lot of tables there. And these are the tables we're going to be using. So we're going to be looking for the critical value for T. So you will go to table 2, which says critical values of T. And that is the table we are going to use. So remember what we had, what we found, our alpha. So we know our alpha was 0.05, and our degrees of freedom, we calculated it and we said the degrees of freedom was 44. The degrees of freedom was 44. So now we're going to come to this table. You're going to look for your alpha. But now, when we look for alpha in this instance, because it's a two-tailed test, remember, if it's a two-tailed test, we're going to have to divide our alpha value. So we're going to say T alpha divided by 2. So therefore, it means we're going to say 0.05 divided by 2, which gives us our T of 0.025. So that will be our alpha or level of significance that we're going to be using. At the top, it will give you all the T alpha values. Since it's a two-tailed test, we have to divide by 2 and we get 0.025. So you come here at the top, you go look for 0.025. Then the degrees of freedom is running down from 1 up until the rest of the other values. So I'm going to highlight this column because I'm going to scroll down so that you can see everything that when I'm scrolling down. So you will get to, on this table, they don't have 44, but it ends at 40 and 45. Usually, some tables, they do have up until 44. So usually at 44, it will be 2145, some number. So for this one, I can see that it ends at 214. So we're going to take that one. We're going to take the 45 value one, which is 214. And you will notice, I will need to go back. Sorry. So we're going to use that 214. But if we go back to my table, because I've used another different table that I am showing you right now, so I need to go back to share the screen again, back to my screen. Okay, so you will notice that now I have 2,0154 exactly like that. But on your table, you're going to use the one you see on your exam, your past exam table, timetable, where it says 2,014. So you can use that one. So because it's a two-tailed test, and that is why we have two areas of rejection. So we create two areas of rejection that will help us when we make conclusions. So we create the 0.14 on one side and we create a 2.15 on the other side. Then remember step number 4 was to state what your test statistic is, and we said it's test statistic. But step number 5, we calculate what the test statistic is all about. So remember, we already calculated this previously before we even come here. So we calculated the test statistic and we found that it was 2.03. Now we need to take this test statistic and the critical value that we got. We come to this graph. It's always easy to use a visualization. Unlike using the normal theory that they have, because it's in a statement, it says for a two-tailed test, if your critical value is less than your t-test, then you do not reject. Or if it's greater than if your t-test is greater than your critical value, you reject the null hypothesis. It's always going to be challenging for you to always remember all this, because when it's a one-tailed test, you need to remember that it's only for the less than. If it's for the right-tailed test, it's for the greater than. But if you're using a visualization tool like this, a visualization format or a graph, it makes it easier, because then now you can see where your region of rejections are. So remember, this were our critical values, and these critical values, they create a region of rejection. It says anything bigger than the critical value where it is, anything shaded in blue, wherever your test statistic falls in that shaded area, you're going to reject the null hypothesis. And because it's a two-tailed test, since we have two areas, whether we get the t-test statistic value of a negative or a positive, we always come back to the graph to see where that test statistic falls. And this is 2.03, therefore it falls somewhere here in the blue area, therefore we can reject the null hypothesis because of this. Then in conclusion, when we conclude, after we make that decision, My screen is stuck. So we can conclude and say we are going to reject the null hypothesis at alpha 0,05 because there is enough evidence that shows that your test statistic is greater than your critical value, and there is evidence that shows that. Therefore, we are rejecting the null hypothesis that states that the mean of sample size of population 1 is equals to the mean of population 2. So it means the means are different. And that's how you make the decision. So let's say you are in the exam now. You need to be answering the question. Remember the 6 steps that we did. If you look at these options that you get from a question that you get in the exam, it states that number 1, the null hypothesis is this. Number 2, it states the standard error. Number 3, it states what the region of rejection is. Number 4, it asks you for the degrees of freedom. Number 5, it's asking you for the test statistic. If we go back, you can see that it asked you for step number 1, for step number 1, it asked you for the critical value, which is step number 4. It asks you your test statistic, which is step number 5, and it also asks you the standard error. And the standard error, remember, it is the square root of your pooled variance times 1 over 21 plus 1 over 25. And that is what you need to be calculating to get the standard error. And it also asked you about the critical value. And that's all, which it means if you know all the 6 steps of a hypothesis testing, you should be able to know how to answer the question. And you have at least 5 minutes to see if you can answer this question, and then we'll come back and reflect together and help you and see where we're going wrong. Let me give you 5 minutes to reflect on it on your own. And if you know the answer to the question, you can also just go ahead and post it on the chat. Otherwise, then we can have a discussion after 5 minutes. Sorry about that. I need to quickly go back out. Remember to calculate your standard error. It's the square root of your pooled variance times 1 over n1 plus 1 over n2. And remember to find the critical value depending on what sign you have in your alternative hypothesis. If it's greater than or equal, if it's not equal, then it's 1 tail. If it's 2 tail, if it's less than, it's 1 tail also. So when it's 1 tail, you will have to find 1 alpha. You don't have to divide by 2. You only use alpha. And to calculate the test statistic, which is T equal your mean for 1 minus your mean for 2 minus your population for 1 minus your population for 2, divide by the standard error, which is your pooled variance times 1 over n1 plus 1 over n2. I
Hi
have
Elizabeth.
technical difficulties.
We still can't
I'm
see
not sure
the.
if you are able to see the presentation. It seems like you're not seeing what I am seeing. For some odd reasons, I cannot put it in a presentation mode, and that's the only way I am able to write on the screen. Let's see. Apologies for that. These are just some of the technical errors that we have. I'm going to share my screen, not the presentation. I hope it will work if I do it this way. I apologize for that. Let me know if you are able to see the presentation. And I think so. So remember, that is to calculate the standard error and to calculate the t-value minus the population 1 minus the population 2, which will always be equals to 0 divided by the standard error, which is the square root of your pooled variance or the pooled variance times 1 over n1 plus 1 over n2. Okay, so let me assist so that when we do the exercises as well, then you are now familiar with how to identify certain things from the question. I hope you have at least tried. So if we read the statement, I'm not going to read every line. We are given that the sample size 1 is 9, the mean from sample size 1 is 42. We are told that the sample standard deviation is S is equals to 41. By them mentioning that S1 is that, then it tells us that the population standard, deviation or the population variance is unknown. If it was known, they would have put the sigma there. So since they are giving us the sample standard deviation, we assume that the population is unknown, the population variance is unknown. So they give us the standard deviation for sample 1 is 4. And they also tell us, remember the assumptions. The assumption was it should be normally distributed, the samples must be independent, and so forth. So there they they tell us that they also selected from an independent sample of n is equals to 17 from another population, and the sample mean of 34 with the sample standard deviation of 5. Then they also go on and say, suppose that an e-tutor wants to determine if the mean population 1, so they're telling us the mean population 1 is less than, and there is your keynote. If they could have said the mean is different, the mean population 1 is different to the mean population 2, then we know that we're doing a two-tail. But because they are telling us that the mean population 1 is less than, since it's less than, we cannot put it in the null hypothesis. We can only put it in the alternative. So therefore, it means it will tell us exactly what kind of a t-test we're going to be doing. Is it a one-tail test or is it a two-tail test? And since it's less than, it means we're going to be doing a one-tail test. And the sign for less than, I'm assuming everybody knows maths in this module, so it is the less than sign. To population 2, assuming that the population variants are equal, which one of the following statements is incorrect? So we first need to find out which one is incorrect. The first one they're asking is the null hypothesis and the alternative. I can ignore the null one and I can look at the alternative where it says the alternative, it says it's less than. And I know that that was supposed to say less than. Therefore, this is the correct one. Then the next step is it says the standard error for mean 1 minus mean 2 is equals to 22. Calculating this whole calculation underneath the square root, we first need to calculate the spooled variance, which is your SP squared, which is given by, if you remember, some of this, let's say, I need to also mention the following. If in case UNISA says we're going back to a venue-based exam in October, November exams, then it means you need to know which formulas are given. All formulas are at the back of your past exam papers. They will be given in there, not all of them, but some of them. They will be given to you in the exam. You need to identify which one you will use to answer certain questions. But since we are going to write an online exam, let's say, for argument's sake, for online exam, you will have at your disposal all the formulas. So, but you need to also know when you read the question, which formula you need to be using. For example, this spooled variance, you will need to know that for you to calculate that spooled variance, you will have to use this formula that looks like this, N1 minus 1 times the variance for the sample size 1 minus N2 minus 1 times the variance of sample size 2 divide by your sample size 1 minus 1 plus, plus your sample size 2 minus 1. And if we substitute the values, remember your N1 is 9. So you're going to say 9 minus 1, and you're going to say your sample variance. They have given us the standard deviation. So for S1 is 4. So we're going to say 4, and we square that answer, minus into bracket. Our N2 was 17. So it's 17 minus 1 times our standard deviation for S2 was 5. So it will be squared 5, divide everything by our N1 is 9 minus 1 plus our N2 is 17 minus 1. So to solve the whole problem, I need to find a calculator. I told you to have your calculators ready. I didn't have mine ready. So I can say the 4 squared is 16 times 8, which is 9 minus 1. 16 times 8 is 288. So the first one is 288, and we go to the next one. 5 squared is 25. Multiply by 17 minus 1 is 16, which gives us 400 minus 400. Then the next, it says 9 minus 1. 9 minus 1 is 8 plus 16. So it will be 17 minus 1 is 16. So it's 8 plus 16 gives us 24. So this will be divided by 24. And 288, let me just double check. 4 squared is 16 multiplied by 8 is 128. Where did I get 288? 16, 4 times 4 is 16 times 8. So you guys, you are just letting me write things that don't exist. You must let me know if I'm making an error there. So this should be 128. And let me double check the other one. 5 squared times 16 is 400. So there it's fine. So 128 minus 400 equals minus 272, because I'm running out of space. Divide by 24 equals minus 1 is equals to minus 33333. So we're going to substitute it into the formula. Minus 333 times 1 over 9 plus 1 over 17. Anybody who calculated it? I don't have my square root calculator next to me. My daughter took it. I forgot to get it back. Have you calculated that? What was the answer? You can post it on the chat so that I don't have to go calculate. Okay. Nobody calculated it. So we can calculate it quickly. Since nobody calculated it there, it's 1 divided by 9, which is 0.11, and 1 divided by 17, which is plus 0.06. And if I add 0.11 plus 0.06 equals 0.17, and I multiply that with 1,133, and I get minus 1 or minus 1, then I get minus 1,93, and I take the square root, which is second function, the square root of the answer. Then I get 1,389 minus, and that is not the correct answer there. And that, it says the standard error for this one is 22, which is not. But if we had to go through the whole statement, we go find the region of rejection. So remember, the region of rejection is your critical value. So let me remove all this and go find the region of rejection by using the degrees of freedom. So remember, T alpha we only have a one-tailed test. So we're only going to use alpha and the degrees of freedom. And we know our degrees of freedom is n1 plus n2 minus 2. So it means for our degrees of freedom is n plus 17 minus 2 should give us 9 plus 17 minus 2 is 24. So our T alpha of 0, did they tell us at 5% level of significance, therefore alpha is 0,05 and the degrees of freedom of 24. So what we do, and we go to, I'll have to not stop, but go out of the presentation mode. Then we go to the table. We go look for the T. Remember our T was T alpha 0,05 and 24. So we go T alpha 0,05, which is that. And we go to 24. We can scroll till we get to 24. And the degrees of freedom is 24. So our critical value becomes 1,711. So if we go back, our critical value or region of rejection is correct. Then, so that was correct. Then the degrees of freedom, we did calculate it and we found that that was correct. The test statistic, so since we have our pooled variance, which was 1,39, that somebody calculated, so we can calculate this. The mean is 42 minus the mean of 34 divide by 1,39 that we got. What did you get? You got 1,3877. Always round off only at the final answer, 1,3877. I'm going to use it the way you got it there. So 42 minus 34 equals 8. Divide by 1,3877 equals 5, did we get it right? That one. It gives me 5,716,756. Do you also get the same? 42 minus 34 divide by, we cannot have two incorrect answers here. Divide by 1,3877. 5,56. 5,76. We cannot have two incorrect answers. So somewhere where we calculated the standard error, we might have done something wrong there. We just need to double check some of the calculation. We cannot have two of them as incorrect. We can have that discussion later on as well. So I need to move on into the next section. So it might be that the calculation we did on the spooled variant, which is 128 divided by 400 is 0,02, 0,32 divided by 24, it gives setup 001. Setup 004. Okay, 128 minus 400 equals divide by 24 equals minus 1,3333, some random number. 1 divided by 9 plus 1 divided by 17 equals divide by minus point, oh sorry, not divide, sorry, I need to calculate again the standard error to make sure that we have the right answer, which gives one divided by 9 equals 0,0. If I write it on the piece of paper, 0,0011, and 1 divided by 17 gives me 0,0588, and I add both of them. So 128 minus 400 divided by 24 gives me minus that. Multiply the answer by 0.011, not 0011, but 01111 plus 0.588, close bracket, equals minus 7.79. Take the square root of that answer and say equal, and I get an error because we cannot take a square root of a negative number.
I think the problem is when we did the pool variance, we subtracted instead of adding on top.
Did we subtract on top? We are supposed to add. The formula, it says we adding, sorry. Yes, we are adding. So I wrote the formula wrong. So you see, if you write the formula wrong, you will get the wrong answer as well. And you will struggle. Thank you for that. So we need to add at the top, sorry. That was supposed to be an addition. Addition. Sorry. Let's go again. 128 plus 400 equals, divide by 24 equals 22. So the answer for the pooled variant, is 22. Still, it's not the standard error, so we still need to calculate the standard error. So the standard error is the square root of 22 times 0,1111 plus 0,0588, close bracket, equals, and it gives me 0. Am I doing something wrong here? 22 times 0,111 plus 0,0558. Take the square root of the answer, and I get 1,9333. And if we go 42 minus 34, divide by the standard error, which the standard error is 1,933, equals 4,137. So our standard error, actually, it should be 1,933. So if we substitute here the standard error, 1,933 on the calculator, I get 4,138. My calculator is in 3 decimal places, so that's why I see 4,138. And if I look at this, it's almost exactly the same. So the only incorrect is the standard error. Okay. Let me check the time because we already took the other time. Do you need to take 5-minute break or we can continue? And look at the inferences between two population means. Okay, Tiffany says continue. So do you agree, guys? Okay, please continue. Thank you. So let's look at when we have two difference of means and we calculate the confidence intervals. So calculating the confidence interval, we're still going to apply the same method that we used, like calculating the pooled variance. So you must make sure that your formulas, you write them correctly. So the confidence interval, the mean 1 minus the mean 2 plus or minus T alpha divided by 2. Now with confidence interval, because we're going to find two areas, the lower boundary and the upper boundary, or the lower class interval and the upper class interval. So we're going to have to find alpha divided by 2 and the degrees of freedom. And we know the degrees of freedom is n1 plus n2 minus 2 times the standard error. And you remember the standard error was that function underneath the square root. And remember, underneath the square root, you have this the pooled variance. Therefore, you need to also know how to calculate the pooled variance. So we're going to use this to find the two confidence interval. And since it has the plus or minus, we're always going to find the minus, which is the lower class boundary, and the plus, which is the upper class boundary. Always, always, always calculate the minus first, because if you don't do that, you start with the plus first, you are going to swap the values around, and you might find that there is a correct answer from the option. So always use the minus first. Minus comes first, then the plus comes second when you do the confidence interval. So let's look at the very same exercise example that we used. We have the sample for the New York Stock Exchange and the NASDAQ. And we want to construct a 95% confidence interval. And in this instance, they give us a 95% confidence interval. It's easy to find the level of significance because a 95% confidence interval is 1 minus alpha 0.95, where if we get the value of alpha minus, so it will be 0.95 minus 1, and if you calculate all this, you will get that minus alpha will be equals to 0, minus alpha will be equals to minus 0.05, and we need to get rid of the negative. We multiply both sides by a negative, therefore alpha will be equals to 0.05, and that will be your level of significance. So it's easy. When they give you the confidence interval, you can calculate your alpha by using the formula 1 minus alpha. Okay, so let's build the confidence interval. The first step we need to do is to calculate the pooled variance. Remember, calculating the whole monster calculation. And we know that it was 1,052 because we calculated it previously. Now, to come to the formula, we need to substitute the values. We know what the mean for x1 was, and we know that the mean for x2 was. Our critical value, which is your T alpha divided by 2 and the degrees of freedom. Remember, we did find this on the table. We did go find the critical value of T 0.025 because alpha was 0.05. We divided by 2 and it was T alpha divided by 2 gave us 0,025, and the degrees of freedom was 44. And the degrees of freedom was 24. And we went to the table and we saw that it was 2,014 on the table that we used. But because of the table that I have, that goes to 44, I'm using that value here. And my value was 2,0154. And then we multiply with the standard error. And when you calculate the whole thing, you get the answer that looks like this, which we can also write this as the following. We can also write it as 3,27 minus 2,53 equals 0,74. So this will be 0,74 minus, and you calculate the standard error this side, and you can write it in this manner. What will be this? Will be 1. Let's start with the 1,502 into bracket 1 divided by 21 close bracket plus open bracket 1 divided by 25 close bracket equals, find the square root of the answer, equals 0,36, multiply that with 2,0154 equals, and the answer this side is, I might be doing wrong things here, 0,7311. And on the other side, we do the same, 0,74 plus 0,7311. And when we solve this, we get 0.74 minus 0.7311, 0,089. Let me just double check. Yes. So you will get 0,008. I'm going to leave it the way the question is because I've rounded it off. 0.74 plus 0.73 is 1,47. And that's all what you can do. You can write it in this manner, or you can put the mean in between. It means one and the same thing. And this will be your lower boundary, and this is your upper boundary. They mean one and the same thing. And that's how you do confidence interval. In the exam, you will find such a question like that. And for example, they will give you a table that looks like this, and they ask you at 95% confidence interval, which one is the correct answer there. So you will need to know the formula, your mean 1 minus mean 2, plus or minus your critical value of T alpha divided by 2 and the degrees of freedom times the standard error, which is the pooled variance, times 1 over N1 plus 1 over N2. And remember, your degrees of freedom is N1 plus N2 minus 2. And what else? Your pooled variance, your S squared pooled is N1 minus 1 S1 squared plus N2 minus 1 S2 squared divided by N1 minus 1 plus N2 minus 1 and you can come here and substitute. So your T alpha, your alpha at 95%, so you will have to find your alpha at 0.05 and your degrees of freedom. I'm giving you 5 minutes and then we'll come back. If you have the answer already, you can share with us on the group and then we can come back and do together.
Hi there, Elizabeth. Can you hear me?
Yes, I can hear you.
Yes. Do you need the support of the DLA?
No, Jacques, the register does not have STA 1502.
Okay.
Please, yeah.
Okay. Okay. I will ask them to update it quickly.
Okay, thank you. How are we doing? Do you have the answer already? Yes, Tiffany, this will be a multiple choice question. You need to select which one is the correct one. Okay, let's do it together. Who wants to start with me? You don't have to give the correct answers. You just need to tell me if we're doing the right steps. We talk to and follow the steps that you did. Anybody? Anyone who wants to take a step? If not, I am going to remove this and going to start step by step so that we can all follow. So I'll start first by doing the critical value, which is easy to find. Our degrees of freedom, our n is 16, plus our n for the second one is 13 minus 2. And that will give us 16 plus 13 is 29 minus 2 is 27. And that will give us 27. So now, to go find T alpha divide by 2 and the degrees of freedom, we know that our alpha is 0,05 divided by 2, and our degrees of freedom is 27. Therefore, our T is 0,025, and 27 is our 25 and 27. Now, we need to going to keep everything and go to the table, go under the T. Let me remove all the workings that we have. We know that we're looking for T alpha 0,025 and 27. So 0,025 and 27. Lucky enough, it's right at the bottom of the screen. So if I scroll up a little bit so that you can see, then we go there and we go there. And that is our critical value, which is 2,052. And if we go back to our presentation, we know that our critical value is 0, not 0, it's 2,052. Now we need to also calculate the pooled variance. Calculating the pooled variance, I'm going to use this and then I'm going to delete it again. So to calculate this, we need to substitute the values. So our SP squared, our N is 16 minus 1. Our standard deviation was 48, so it will be 4, so it's 4.8, and we can square that, plus 13 minus 1, 5.9, and square that, divide by 16 minus 1 plus 13 minus 1. Then if we calculate what is at the top, we get 345,6. If I'm getting different numbers as you are, let me know. You can unmute and tell me. I'm not looking at the chat. 417,72 divide by, if I calculate everything, so it's 15 plus 12, I get 27. And to get the answer for this, we have 345,6 plus 715, that divide by 27. The answer I get is 28.2711. Agree? Are we all on the same page? And that is the spooled variance. Now we need to go to the formula to calculate the let me change the color and use the blue one. So let's now calculate the confidence interval. Mean 1 minus mean 2 plus or minus T alpha divided by 2 and the degrees of freedom times the standard error, which is our spooled variance squared times 1 over N1 plus 1 over N2. Substituting the values, we know that the mean is 34.6 minus the mean of 32.2 plus or minus our critical value. We did go find it. Remember, the critical value was 2, which was 2, 0, which is that critical value 2, 0, 5, 2, and times the standard error, which gives us the pooled variance, which is 28,2711 times 1 over 16 plus 1 over 13. And solving this, we get, I didn't get that far, so 34.32, 34.6 minus 32.2 gives us 2.4. So this side we get 2.4 plus or minus 2,0552, and if I take the square root of everything that is underneath the square root, if I calculate everything there, I get 3,9416, and then I can solve the whole problem. So if I take the square root of that answer, I get 1,9853, and then I need to multiply that with the critical value, which is 2,054, and I get 2.4 plus or minus, I get 4,0778. Let's say 778. Now I need to split it into 2. Since I'm running out of space, I'm going to write here at the top, or I can just write it here. So we can substitute. We start with the minus first, 24 minus 4, 0. I hope you are able to see what I am writing there. Is it visible? Four, 0.0778, and I must also repeat the same, 2,4 plus 4,0778. I hope I did do service to this. So if we say the minus first, 2.4, and I get minus 1,67. You get 1,67. It might be because I'm rounding off so many numbers quickly. Do you get the same number that I'm getting? You have to talk to me. So somewhere I might have rounded off too quickly. So number 5, 1,767, and 2,4 plus 4,0, and I get 6, 1, so the answer is option number 5, 6,47, and which is option number 5. So I get 1,67 and minus 1,67 and 6,47. Those are the values I get on my calculator. Do you have any questions? We are 4 minutes.
Elizabeth? Elizabeth, can you hear me?
Yes, I can hear.
Yes, I just want to say that they are busy updating it, but it will take time to kick in the attendance register, whether it's possible for students just to sign their student numbers in the chat room.
Yes, they did sign into the chat room.
Thank you, Elizabeth.
They did their student numbers in the chat room. So you will find some. So those who are still busy, you can also write your student number in the chat for the attendance register. Okay, do you have any questions? In the absence of the question, then I can just recap and mention we were going to do an additional exercise, but because we started late and the session was not a full 2 hours, but we do have a lot of other exercises from the document that you can go through. I will post the document in the folders, and you can have access to them. So you will have to go to My UNISA under the Western Cape region site to access the recordings and also to access the notes for all the sessions that we're going to have. To recap on what we did, we looked at independent population where the population variance is unknown, and we looked at how we calculate the hypothesis testing. And I mentioned that you need to know the 6 steps of hypothesis, especially when you answer questions on the hypothesis, because all the options might be one of the steps of the hypothesis. Also, to remember that you need to know the formulas. You will, from today until you go write the exam, you will be introduced to new formulas every day or every week that we meet. You need to know which formula calculates what, because even when you go to the past exam papers at the back, they are not stated. There is nothing that states that this formula calculates the inferences. This formula calculates the ANOVA. You will need to make note for yourself so that when you go write the exam, you have a set of formulas that you know and understand, and you know which formula applies where. You also need to know how to calculate those formulas and how to do a proper substitution. For example, when we looked at the pooled variance, you can see that they give you the standard deviation. Therefore, you need to calculate the variance by squaring the standard deviation. We also looked at how to calculate for the same inference where the population variance is unknown, how to calculate the confidence intervals. Also applying or building onto from the hypothesis testing, where we looked at the standard errors and how to use your tables to go find your critical values. It is also very important because from today until you go write the exam, you will be introduced to new tables on a weekly basis. You need to know which table applies to which type of question. And it relates to which section in your study guide as well. Thank you for joining today's session. I am going to share with you the link to the WhatsApp group that I have created. We started this last semester. You can join the WhatsApp group. Anything you want to discuss that we didn't touch today, or anything that we touched today, we discussed, and you're still unsure about, feel free to continue the conversation on the WhatsApp group. If you need help with your assignments and so forth, if you want to discuss with your fellow students who are in this online session, you can do that on the WhatsApp group. I will be there to monitor the conversation. Please use it responsibly. Don't spam the group with adverts and selling and marketing and so forth. That is meant for STA1502 content discussions only. Thank you and enjoy the rest of your evening. I will see you next week, Tuesday from 5 o'clock. So next week we go back to normal. The classes will be 2 hours from 5 o'clock until 7 o'clock. Thank you, guys. Remember, those who haven't put their student number in the chat, please make sure that before you switch off, you put your student number on the chat. I am also going to post on the chat the link to the feedback form. Please make sure that you complete that. For every session, we are going to have that. Make sure that you complete that. And if you don't have time to complete it now, I will post it on WhatsApp as well, so that you can complete the feedback form as well from there. Thank you, guys. If you have anything to say, you can say it. I've been talking the whole day. I don't even know how your voices are. You can unmute and talk to me. I'm not going to give the WhatsApp number, but if you type this link in your browser, because if I give you a WhatsApp number, then it means you have to ask me to add you to the group. So in this way, you can add yourself. Type the link the same way as you see it. Where there are small letters, type the small letters. Where it's capital letters, type the capital letter. You can even try it right now. You will gain access immediately. You go to your web browser on your phone and you type https://bit.ly/STA1502-PAROW. That will be it for today. You can unmute and talk to me. Nobody. Okay. Enjoy the rest of the evening. Bye.